Okay, thank you. So in this talk, I want to summarize some recent developments in SparkR, the R components in Apache Spark, and I want to just with a flavor on advanced analytics. Just a few things about myself. I'm a technical lead for machine learning and data science at Databricks. I'm also a committer to Apache Spark, and primarily working on the analytical components of Spark, like MLlib, GraphX, and SparkR. And I did my PhD in computational math, basically just implementing a lot of numerical algorithms. And for today's talk, I'm going to just do a very brief introduction to SparkR. So, and before I do that, so if you use R, please raise your hand. So I want to see. Great. So then I want to talk about some basic descriptive analytics in SparkR. Then I move to more advanced analytics like machine learning in SparkR. And then we talk about some future ideas for future directions. So first, SparkR was initially developed at UC Berkeley MLlib as a research project. And it was contributed to Spark in 1.4. And basically, it's a thin wrapper over Spark data frames, and it provides some data frame-like APIs. And so in SparkR, we try to just make the APIs very similar to existing APIs in R or popular R packages. And this is kind of different design choices to other APIs. In Python, Scala, Java, we try to make the API very consistent across languages. And there are a couple of reasons we wanted to do that. And first of all, R is loved by many, many data scientists for its really concise and expressive APIs. And they are very simple to use to deal with data. And we don't want to change that part. The problem the data scientists are hitting is scalability. They want to deal with bigger and bigger data and data that cannot be fitted onto a single machine. And so we want to fix the scalability issue, but we want to keep the user-friendly R API. So that's the main goal of SparkR. And you can look at this DataFrame-based APIs in SparkR. So building on top of Spark, SparkR can talk to just many data sources and in just different data storage, like on S3, HDFS, or local file system. And you can just deal with data like CSV, which R already have built-in support. And you can just play with Parquet files and JSON files. And it's just connected multiple data sources. And then if you're an R user, you'll be very familiar with the data frame-like operations we provide in SparkR. And if you have a Spark data frame, you can easily convert it to R local data frame. And then you can use some single machine tools to just, for example, to do some visualization and then do other manipulation on your data. Yeah, this is just one slide to introduce SparkR. And for people who may be interested how we implement SparkR, and this is just a brief picture about the architecture of SparkR. The orange color is basically Spark sitting inside JVM. It's the Scala implementation of Spark. And on the right side, the Spark can talk to just multiple data sources. And Spark has just many workers in a cluster and a driver and inside JVM. To implement SparkR, we put the R process on the driver node, which can talk to the Spark driver through a socket, and then basically pass instructions about how to operate on a data frame through the socket. Or if you call, let's zoom out about the driver part. So if you call SparkR collect on a Spark data frame, it will convert the data into a local R data frame. If you call create data frame on an existing R data frame, it will give you a distributed Spark data frame. That's basically the data conversion between single machine R and SparkR. And it's a very brief introduction of SparkR. If you want to learn more about it, you can just go to, there's a webinar about SparkR on our company website. And let's move forward to some descriptive analytics. You have a really large data set. You cannot examine just every single record in this data set. You want to summarize it first and get some basic ideas about your data sets. And we provide just a basic summary statistics in SparkR, and something like a mean, variance, and standard deviation, and the simple ones, and then bivariate summary statistics like correlation, covariance. We also offer the higher order summary statistics like skewness, kurtosis in SparkR, all under the DataFrame APIs. And we also have sampling algorithms. If you want to just see, let's have a representative subset of my data and want to collect it to local and then use ggplot to just draw it out so I can see a visualization of my data. We also have this random sampling with or without replacement or even stratified sampling. And it's, again, all under DataFrame's API. And on top of those basic methods, we also implement some fancier algorithms like approximate algorithms. For example, to get the quantiles, it's very hard to get the exact quantiles for very, very large data sets. And we implement approximate quantiles because in most cases, and that will be sufficient for our users. And we also have just an algorithm to look at frequent items. So it's basically those algorithms will help you to understand, just give a quick description, quick sketch of your distributed data set. And those are the algorithms. Let's slightly just talk about the implementation. We use this pattern called aggregation pattern that appears many times in Spark. And it's called, you can say, split your data sets and then do aggregate each partition of your data set and then combine the partially aggregate result to somewhere as your final result. So if you are R user or if you use dplyr, I think this is well, a pattern you're already familiar with. And so basically, we implement those algorithms under this aggregation pattern. And now, if you have a distributed data set, and you can just split your data into small chunks, and then it will certainly get some speed up, right? So if you want to compute some summary statistics, you want to get it fast, we can tell you, oh, if you have 100 machines, 1,000 machines, and then you can definitely just get maybe something close to 100x speed up. And so, but for many implementations, that's kind of end of the story because we already have scalability, so you just need the money to buy more machines. But that's not the end of the story for us. So we really want to have a very good implementation of those algorithms. And we did actually just many things, but two things are, actually we develop new algorithms that can just give us summary statistics faster with less number of floating point operations. We also just take the advantage of the low-level optimization of Spark data frames to use code generation to achieve some just very high performance of the implementation. I did a small just benchmark on my laptop, basically computing the kurtosis of 1 billion values. You can actually do it on a single machine. I listed some numbers here. So if you use SciPy, and it took more than 4 minutes to just for the computation, and Octave is a language similar to MATLAB. It takes about 2 minutes. And R, there's a popular package called Moments, and you can use that to compute kurtosis. It took more than 1 minute. But with Spark, even just on a single machine, it took only just 5 seconds to finish and uses both cores. And if you have a cluster like 10 nodes, it may just take less than 1 second to finish. So we really want to just make our implementation well, also has very high performance, not just scale out to many nodes. And yeah, that's just a quick summary about just descriptive analytics. Let's move on to the topic today, predictive analytics. Basically, this is more advanced analytics. You want to, for descriptive analytics, you want to take a look into the past, right? You want to look at existing data sets, what they look like. And for predictive analytics, you want to build models. You want to build predictive models, and you want to predict for the future. And so we did this. People may already know that we have a machine learning component inside Spark called MLlib. And we started the integration of MLlib and SparkR since 1.5. And so we try to just add more porting more machine learning models to SparkR and expose that to our users. And again, so we think about these API choices because there are some existing algorithm in R. So the best maybe option for us is just to mimic those existing methods in R. So they don't need to just modify the API. They just replace the R data frame by the SparkR data frame. And then everything works. That would be the very ideal situation. However, so as we just adding more algorithms, we found out there are a couple issues. The first issue is, so for some algorithms, because of the implementation, we cannot really just match those existing methods 100%. So they are similar, but they are not the same. So that's an issue. For example, we can say if a user just try to switch to SparkR, and there are some missing features, but they just assume that it should work, but it didn't work that way. Also, if we use the same name for the methods, and there may be a chance that we can just shadow existing methods if user want to import both libraries. And then we look at put all the methods together. We found that because R has a large collection of R packages, and those APIs are not very consistent across languages because they were developed by individual contributors. And if we follow each one of them and putting them together, we don't have a consistent API in SparkR. So there's another option to say, create a new set of API in SparkR that is consistent. And we pick option 2 here. But if there's a method, we can guarantee that we match all the features, and we won't just cause conflict with existing methods. And then we try to just also implement option 1 here. Let's move to some models we have. Let's always start by this generalized linear models. It's kind of the simplest and the most popular machine learning model here. And it just try to make prediction by a linear product between the observations and the model coefficients. And to specify a generalized linear model, you need to specify an error distribution called family and then a link function. And basically, the model is to maximize some log likelihood. In Spark 2.0, basically, we introduced generalized linear models to SparkR in 1.5. That's the first integration. But we keep adding more features to generalized linear models. In Spark 2.0, and this the coming release, and SparkR will support all the family and the link function combinations supported by R. So basically, it should be very easy for you to port your existing workflow to SparkR if you use generalized linear models in R. And this is one example how to use generalized linear models. And you load a data frame and to call read.df that will load a Spark data frame from external data sources. You have two options. Basically, we offer just 2 APIs here. One is very similar to R's own GLM. You can call GLM with a model formula, and then the data frame, and then the family and link functions. You get the model. And after you get the model, you can say a summary to see the summary statistics. And then you can make predictions using predict on some new data. And another option is you call spark.glm. That's the option 2 I mentioned in the API design choices. And you start with the data frame, you describe the family, and then with some required parameters and then optional parameters. And for methods start with spark.dot. Those methods we try to make them consistent across SparkR. And next, let's just talk about how we implement those machine learning methods in SparkR. And it is actually very simple. It only took us maybe just 100 lines for the implementation. And it's just a simple wrapper over the ML pipelines and in MLlib. So basically, a linear model in SparkR is just a pipeline with 2 stages. The first stage is called R formula. It's a transformer to just figure out, well, the feature types in your data frame and what features you need for training and what's the target label column. And they try to do this feature processing and generate some feature vectors for the estimator. And then the second stage is this generalized linear regression that the estimator actually trained the model. And the wrapper is just a pipeline chaining those two stages. And this is on the left, you see this pipeline is R formula first, and then generalized linear model second. Those implementation are in Scala. And then if we zoom out about R formula, and it has embedded pipeline inside R formula that deal with all the string encoding, dummy coding, and then how to assemble the feature vectors into a sparse vector in MLlib, and then how to map the encoded labels back to the target label. So it's a very flexible API implemented in MLlib that makes the SparkR integration very, very simple to implement. And for R formula, we support a subset of the features supported in R. Those are just the most important subset of operators. And you can use that, I think you can use that in most implementations. And this is implemented in Scala and also made available in Python, R, and Java. And for the implementation, we try to be very careful here. We try to make the results the same as R's output. So just make existing R users very confident about moving their workflows to SparkR. So basically, this is some code snippet in our test. We just say, this is how you produce the results in R, and this is the target value we test against. It just make them the same. And beyond linear models, we also support other ML machine learning models in 2.0. And there's accelerated failure time model for survival analysis, and k-means clustering, and also naive Bayes. And we support the Bernoulli version of naive Bayes. So there, I'll also put the popular packages we try to just match. That's a survival package for survival analysis, and this E1071 package for the naive Bayes. And in 2.0, a big feature in MLlib is model persistence. We also support model persistence in SparkR. So in practice, well, data scientists usually do some ad hoc analysis, try to figure out what would be the best model for them. And then they want to productionize. Well, they send it, okay, those are the model parameters. They send it to maybe software engineers and ask them to deploy to production. And then the software engineers, they need to figure out, how you make predictions and how to understand the data format. If you just call save in R, it will save just a binary, save the object in binary format. And then it cannot be decoded in other systems. And that's very hard. But we implement this model persistence for all the models in SparkR. So it's very similar. You just need to call write.ml with the fitted model and the output path. And then you can load it back in SparkR. Well, because we use a very just exchangeable format for model serialization, it's basically JSON plus Parquet. And it's very easy to say, well, you can hand it over to some software engineers and then say, this is our data, you can read it back. Actually, you can read it back in Scala or Java on the Spark side. So they can just read it back and either make offline recommendations and try to deploy the model to production. And this is how we work with distributed data sets, but also just how to just work with existing features in SparkR. But we know that R has a large community, and R on C-Run, and there are more than just 8,000 packages. And well, even with, well, SparkR is a very popular project, it's definitely impossible for us to match every single feature for existing R packages. And also, in the real world, we talk about big data a lot, but not every single data set is big, right? So many people, they are just working with small or medium data sets. But we think SparkR is also a good fit in those scenarios. For example, well, you can use SparkR to connect it to different data sources, and data on local, data on distributed system, data sitting in a database. And you can use data sources to just connect them together and try to just do some data manipulation. And then you can use SparkR to filter the big data sets. And maybe you only care about small subsets, and your model training only need that small subset. But your data maybe just need to be filtered or downsampled from a large data set. You cannot use a single machine R to deal with them. But SparkR provides a good approach to just connect the big data with single machine R. And also, for model training, and usually you want to tune hyperparameters. And you want to tune just a many combination of them and try to find which combination works the best. And this is an embarrassingly parallel job. And you don't want to do that on a single machine. And actually, I believe, because it takes much, much longer, you need to train maybe 1,000 models one after another. And I believe that in practice, many people don't do that because it takes too long to train to just cross-validation dating models. And Spark can help to parallelize those embarrassingly parallel tasks on Spark. And you don't need to worry about how to schedule your job, how to monitor it, and how to allocate resources. Let's take a look at one example here. And you can get a data frame from some data sources. And then you can say use a data matrix, and you collect it back to your R local driver. That's start from a single machine. And then you can say convert it to a data matrix, and in order to call the k-means just a method in R. And then you can define your task. I don't know, well, how many clusters I should use. I want to look at the data, I want to look at the cost, and try to figure out which K is the best here. I want to try maybe from 1 to 6. And in R, there's a method called lapply. You can easily use that to apply a function to a list of values. And you can say lapply kk is 1 to 6, and then run k-means on it. But it will run it in a sequential way, and it won't parallelize the jobs. In Spark, we provide this method called spark.lapply. And you only need to say, this is the Spark context, and this is the list, and this is the task I want to do. And Spark will automatically parallelize the job for you. And so, well, it depends on how many nodes in your cluster, and you will get certain speed up. So that's the way, well, we can see how Spark fit into just this single machine or small or medium data set scenario. Yeah, just a quick summary of this talk, as you do summary in R. So SparkR really just try to enable big data analytics for our users, for many data scientists. We have descriptive analytics built on top of data frames. We also have predictive analytics from the MLlib integration. And SparkR try to also work well with existing R packages and work well with single machine scenarios. And yeah, this is definitely, well, I didn't implement all the features, and actually I only contributed a small portion of it. And this is a community effort. I want to just thank all the people contributing to SparkR and maintaining SparkR. So there are a few companies, developers from Alteryx, Berkeley MLlib, Databricks, HunterWorks, IBM, Intel, and there are some individual contributors. I want to thank them all. So let's talk about some future directions. And SparkR is very young, and it's growing very fast. And there are definitely just many things we can do about SparkR. So I just list some important ones, from the basic data manipulation to advanced analytics. I want to make a serial release of SparkR just to make SparkR more accessible to our users. Right now, you need to build a Spark cluster and then open a SparkR shell. Oh, there are some integration you can do in RStudio, but it's not that convenient. It's not as simple as install packages SparkR. So we want to make that part easy. And want to look at just how we make our APIs more consistent with just existing R packages and those popular ones like dplyr, for example. So basically, we know that we try to make APIs very similar to existing R APIs, but they are not 100% the same. And that created some issues with our users from migrating their workflow to SparkR. We try to make a better job here. And there are definitely just some issues because for certain operations, it's very, very expensive to just implement them on a distributive data set. I also want to just document those clearly. So for advanced analytics part, we want to provide just a better R formula support. And you can do more operators and just describe more complex models in SparkR. And then there are definitely just more algorithms coming to SparkR from MLlib. And there's a working in progress for the decision trees. And we're also just porting over alternating list squares for recommendation. And because of this ML pipeline implementation, essentially it's very simple to port over algorithm that's 100 lines of code. But we need to discuss more about, for example, the API, how to make them consistent, how to maintain the backward compatibility. And there's some work on just the integration with existing R packages. For this one, like a group apply, you want to do a group by, and then you want to train a model for each group. That's basically if you have a user segment, you want to train a model for each segment. And then there are basically some work on the UDF support. We already have partial support in SparkR, but we want to make that part better. And there are also just many third-party Spark packages. And we're also considering just adding R APIs to those packages. One of them is graph frames. And just it's very popular Spark package building the graph API on top of data frames. And so basically there are some definitely R users who want to analyze social network data, and we want to make that work for graph frames as well. There are also just possible integration with NLP package, and just make them available in R. So yeah, so basically you see that there are really just many things we can do. There are many options here, but we would like to hear the feedback from the R community about what features they want to see in SparkR. What are the major issues they hit when they try to use SparkR? We want to collect those feedback and see, clearly which direction we should go. And if you have any feedback, you can talk to me after this talk, or you can send just a message to Spark user or dev list. And for this talk, I also made a notebook and to just list all the commands I mentioned in the notebook. And it's available. Oh, I cannot click it. Let's try this. Is it here? Yep. So it's available, publicly available. You can see those are the sections I mentioned on how to try the methods for each step. And you can definitely just sign up a Databricks Community Edition. And then, let's see, where is my page? Yeah, here. Yeah, I will just upload the slides to the website. And you can go to databricks.com/try to just sign up for a free version of the community edition. And there's some documentation you can look at. The main one is the user guide on the Apache Spark website. And there is also just a roadmap Jira talking about what features we want to implement in 2.0 for MLlib, and it also covers SparkR. And just please put your comments on the Jira, and we will definitely consider that. I'm doing the office hour after this talk this afternoon at the Summit Theater, or then at the Databricks booth. If you have just things you want to say about SparkR, definitely talk to me. And thank you.
Any questions? Don't forget the office hours. He's going to be there for an extended amount of time, so we can actually keep this short and keep going. I know it's lunchtime.
There's a lot on regularized regression in Spark. There's a very good package, GLMNet, in R. Have you looked into doing regularized regression where you can go back and sort of balance out L1 and L2 constraints?
Sorry, I didn't hear you. It was a little bit noisy.
There's a lot going on of regularized regression in Spark. regularized regression. Okay. So are you doing anything with GLMnet, which is a very good implementation in R?
Yeah, so we spend lots of time on just implementing algorithm that is same as GLMnet. And the implementation is already available in MLlib. If you look at the test, basically we test, this is to test against R's GLM. This is a test against the GLMnet. Because it uses some special standardization on the features and the labels, we try to just mimic that behavior and make sure we output the same. So it's now in MLlib, but we are just porting it over to SparkR maybe in the next release.
Just a follow-up to that, does the MLlib implementation do grid search automatically for the hyperparameters as the package does in R?
Yeah, right now we don't do automatic research, and you need to put a wrapper around that. Even for the implementation in MLlib, we have this cross validator. It's just sitting on top of existing implementations and try different combinations and select which one is the best. It's different from, for example, if you have the regularization path, and you can just find a smart implementation that can pick the cross-validation results cheaper, just faster. We don't have that.
Just a quick question. Do you have like EM, expectation maximization, already in SparkR?
We don't have it. It's a very general framework, right? So I think once we implement the UDFs, it should be easy for you to implement your own EM algorithm. For example, let's say we have some EM implementations in MLlib, but it's customized for particular algorithms like LDA, if you just call it EM.
If I have a package that uses EM, like R package, can I use SparkR?
It depends on the UDFs, and also maybe the L apply or G apply, and we need to wait for those features to use them.
So you briefly mentioned that it's impossible to convert all the R packages. Do you have an idea of the rough percentage coverage that we have right now?
Yeah, so there's a talk tomorrow by Hongxin, and we are going to talk about the usage we have seen from the open source Spark. What libraries are used frequently with SparkR? And then we know if we want to just port over the features, what package we should look at. Yeah, it's tomorrow.
We're going to take a last question. He's going to be at the office hours. If you have more questions, please stop by. It's lunchtime now.
Okay, thank you. The question is, SparkR is a wrapper on ML or an MLlib, actually?
SparkR is a wrapper over data frames. And for the implementation, it used the pipeline API from Spark.ML package.
From ML, not MLlib, actually,
because it's a little bit confusing here. So there are two packages under MLlib. It's called Spark.MLlib and Spark.ML. And SparkR is a wrapper over the Spark.ML, the pipeline APIs.
Okay.
All right, thank you.